So yeah, 3 years ago, I started a PhD under Steve Powers, and it's quite an experience. You get to travel the state, you get to spend a lot of time looking at this absolute beast of a species. Now, why look at wild radish as a PhD? Well, simply because it's such a genetically diverse species that produces such a large amount of seed. It's been able to evade herbicide application, and it's also been able to develop resistance to a wide range of herbicides that we use. And today, I just want to I've got the unenviable situation of talking about the fact that we found glyphosate resistance in this in wild radish. So WA farmers have shown the ability to rapidly adapt the way we farm in regard to problems. When we look at the stripe rust epidemics of a few years ago, WA farmers were really able to get over that problem by controlling the green bridge. And then after that, WA farmers were able to overcome or limit the spread of glyphosate resistance in annual ryegrass. And this is a real pro for WA growers. WA growers really are the best in the world when it comes to being able to manage resistance issues. And we're able to go forward and control the wild radish problem that we have. So in 2010 and 2011, I looked over the entire WA wheat belt, looking for glyphosate, wild radish populations that were able to evade glyphosate. And what we found, what I actually did find, was 3 separate populations. 2 populations that were able to evade, that were found in glyphosate maintained fallow, and a single population that was found in GM canola. And today I want to introduce those populations and introduce the fact that we do have an opportunity here. Because we found these populations so early, we really are looking at the canary in the coal mine, okay? So we're able to do something about it before this becomes a widespread reality. Why should we really try to protect glyphosate? Well, fundamentally, glyphosate is king. By far, glyphosate is the most efficient, effective herbicide we have in order to control wild radish populations. It's so far in front any other herbicide option we have that it's far beyond the straight when it comes to any other options. We're also becoming more reliant on glyphosate when it comes to summer weed control. Before, predominantly, historically, we've used a lot of auxin herbicides over summer, but we're becoming more and more reliant on mixing auxins with glyphosate over summer, so selections are getting greater, and we need to take that into account. And we also have brand new technologies that have only just recently been released when it comes to glyphosate-tolerant canola. These technologies are absolutely fantastic, and we need to do whatever we can to protect them. So how does wild radish historically, how does wild radish respond to glyphosate? During the study, we took 3 separate wild radish populations, one from Una in the north, one from York, and one on an island called Carnac Island, just off the West Australian wheat belt. These were susceptible populations, and what we found was we had rapid control at around that 540, at just above 540 grams, which is our label rate. So normally, across the state, our populations are incredibly susceptible. So in this slide, we have War 7, which is our base population from Una, Western Australia. When we add War 33, which is our base population from York, it operates in exactly the same way. Very, very susceptible. And our third population from Carnac Island off the West Australian coast operates the same way. So what we can see here is that wild radish across the state operates in exactly the same way when it comes to glyphosate application. But what about these resistant varieties? What happens when we use glyphosate annually, if not biannually, for over 20 years. When I pull those results, I get an LD50 of 411 grams per hectare. Now, what's an LD50, you might ask? It's the rate required to provide 50% control in that population. So when we look at a glyphosate-resistant population, this population was collected from the northern wheat belt of Western Australia. This population had an LD50 increase from 411 grams per hectare up to 1,434 grams per hectare. So it was a 3.5-fold increase. Now that doesn't really sound like that much, does it? But we ended up having over 20% surviving, equivalent of 6.25 litres of Roundup 450. And that's far higher than we normally apply in the field. When we look at our second population from the northern wheat belt, this population had an LD50 increase from 411 up to 1,863 grams per hectare to provide a 50% level, 50% control in the population. So that was classified as being 4.5-fold more resistant. So this one's a whole lot more resistant. Dangerously, we have a long tail to this dose response curve, where we have approximately 20% of the population surviving 9.4 litres of glyphosate and 11% of the population surviving 12.5 litres of glyphosate. So additional selections on these populations are going to increase the resistance level. So therefore we have to be very, very careful. So what does that look like in the field? Here I have two pictures, and we have a susceptible and a resistant at 450 grams of glyphosate, which is our sub-lethal rate. And as you can see, what we can see here is we have 3 pots of our 3 susceptible populations, and the biomass is dramatically reduced at a sub-lethal rate. And in the resistant, biomass was barely affected. At the above label rate, so approximately 1.5 times the label rate, at glyphosate at 750 grams per hectare, all the susceptibles were significantly controlled. Not one of them went on to flower, but we had no reduction in mortality in the resistant, and they all went on to flower. So there is a significant difference in these populations. Glyphosate has moved these populations. Glyphosate use over 20 years has moved these populations towards resistance. And when we look at the full dose response curve, the label rate has been marked by these red lines. And as can be seen from on here, we have dramatic levels of control at the label rate. Above the label rate, we've basically got nothing that has flowered. But when we look at the resistant populations, there's massive amounts of survival at the label rate. So these populations have significantly shifted through glyphosate use and glyphosate management. So what else was it resistant to? Glyphosate, wild radish in the field is currently resistant to 4 separate modes of action. In these populations, were resistant to 3 of those modes of action plus glyphosate. So these populations were resistant to ALS inhibitors, so your SU herbicides, your chlorsulfurons, your mazamoxes, the PDS inhibitors, diflufenicin, and the synthetic auxins, so your phenoxys, MCPA, and 2,4-D esters and amines, and glyphosate. So the question is, we found 2 populations in glyphosate maintained fallow, but how many other populations were out there? Following this, I surveyed 239 GM canola fields. Now we surveyed those predominantly because they had been screened with massive amounts of glyphosate with no other selections or no other herbicides applied to those fields. During that survey, I surveyed over 24,000 hectares of GM canola, and we found 70 wild radish populations that were present in GM canola. Following detailed dose response studies and screening of those populations, we found 1 sample that had 3-fold resistance. So what we can see here is that this resistance is still quite rare. And therefore we have an opportunity to get over it with some prescriptive efforts to reduce population size. So when we look at resistance evolution, it's a twofold effect. We have the screening of the herbicide, and we have the population that it's screened against. So Steve Powles has been talking for many years about increasing the diversity of selections across our weed species. But what we also need to understand is that some species are incredibly genetically diverse, and when we screen massive populations, we are going to look for rare individuals with rare traits. Therefore, we must do our best to reduce our population size. How do we do that? How do we reduce our population size? As could be seen, I'll quickly go back. When we look at the population dose response, we see a massive reduction in the biomass of these populations. Therefore, there is an opportunity to control them. And that can be done through maximising crop competition. At all times, when we use glyphosate, we must make sure that it's done under a highly competitive environment. This was some work done by Pete Newman back in 2012, and on a previously untreated site, so no herbicide applied, there was a massive reduction in the biomass and the yield of wild radish. So wild radish is highly responsive to crop competition, especially if it's been treated by herbicide. And secondly, wild radish does have an Achilles heel. It maintains its seed up till harvest. When it comes to integrated weed management, the whole issue is trying to stop that seed from hitting the soil surface. So we really need to widely adopt and do it well, and do harvest weed seed control well. And when it comes to, and AHRI and GRDC have done a lot of research into this area about maintaining, eliminating seed, minimising seed set. While harvest weed seed control is able to intercept 95% of wild radish seed, and of the wild radish seed intercepted, heat treatment or impact from the HSD, 95% of that is controlled. So it's 95% of 95%, so there's a significant reduction in seed set. So when it comes to the action, when it comes to what are we going to do about this, we need to absolutely increase the diversity of what we do out in the field. And we also need to reduce our population size. We need to not rely on glyphosate, so therefore when on a good thing, do not stick to it, and do whatever we can to eliminate seed set. Unfortunately, when the standard we walk past is going to be the standard we're going to have to accept in the field. Therefore, if we walk past patches, we're going to have to understand that those patches may take over that field. And secondly, it's all about information. Now, AHRI does do its level best to extend its information as fast as humanly possible. So please, get onto the AHRI website and get onto AHRI Insight. All this information will be on there tomorrow. Thank you very much, and if there's any questions.
Mike, Jeff Fosbury. On the two sites that you got from fallow paddocks, when you went back, I presume you went back and reviewed what they'd done for the last 10 to 20 years. Were they into fallow for a good period of time, or were they just beginners?
No. It was basically a very, very similar rotation that you see across the state. So it was a wheat, lupin, and some canola in there as well. Not a lot of fallow, but interestingly, there were annual, if not biannual, applications for over 25 years of glyphosate. So there's nothing different about what these growers were doing. They were doing similar to what every other grower does, and that's the issue here. This really is the canary in the coal mine for us. What's happened here could pop up across the state, and we need to be as proactive as possible to minimise that from going on by reducing our populations and diversifying as much as we can.
Abul Hassan Dafwa. Thanks, Mike, for a nice presentation. It is a bad news for us, but my question is, While radish is sometimes not easy to control with glyphosate, especially related to the stage of growth, but there is a huge variation in the wild radish phenotype. Sometimes we come across with wild radish that has hairy kind of growth on the leaf and stem. Any plant that has hair or waxes on the leaf surface is also difficult to control with herbicide like glyphosate. Did you see any difference between the resistant and the susceptible one in phenotypes like hairy growth or
No.
pubescence on the leaf or stem, something like that?
The mechanism associated with this resistance has not yet been investigated. But there was no difference. There was no real difference in the biotype, in the growth, in the branching of these populations. And the leaves seemed to be quite similar and quite large. So no, there wasn't any difference at all. What we really need to do is to start looking at how to increase the diversity within Roundup Ready systems. You know, we need to maximise the biomass of those crops. We need to incorporate residuals into them. And of course, use harvest weed seed control absolutely at all times.